This lesson is on combining like terms and specifically on simplifying expressions, which we'll talk about later. Let me give you a few vocabulary words that are going to be important for you to learn. The first vocabulary word here is the word terms. Terms are all those things that are separated by addition or subtraction symbol. So in other words, here's an addition symbol. On each side of it is a term. There's one term here and another here. So there are two terms in this expression. The next example has a 2x, a negative 4x. Notice how I said that. When I talk about a term, I also pull in the sign or the operator in front of that term. Okay, so the operator tells me whether that term is positive or negative. In this instance, this 4x is negative, so I say it as negative 4x. And then I have a positive 10. So I have 1, 2, 3 terms here. So all those things around the addition and subtraction signs. The next vocabulary word is coefficient. The coefficient is the number in front of the variable. All right, so again, it's the number in front of the variable. For example, it says circle the coefficients in this expression, and I've already circled those for you. What you are looking for are the variables in each term. So if you notice, I have 1, 2, 3, 4 terms here. So I'm going to check each one for a variable. This term has a variable, so the number in front of it, this 8, is the coefficient. This term has a variable, y. The number in front of it is a positive 9. Notice how I grabbed on to that operator there to tell me whether this 9 was positive or negative. This 9 is the coefficient. This term is just a plain old 4. There is no variable here, so the 4 is not a coefficient. I've got another variable here, so the number in front of this variable is going to be the coefficient. But I don't see a number in front of this variable. However, what you need to remember is that any variable by itself has a coefficient of 1. So the coefficient for this x term is 1. It's kind of like if I said I have a balloon. I don't need to tell you that I have one balloon, because saying that I have a balloon tells you that I have one balloon. It's the same thing here with the variable. If I just see a variable by itself, I don't need the 1 in front of it to tell me that it's 1x, because I just see 1x. So the coefficients in this expression are 8, positive 9, and positive 1, or 8, 9, and 1. The next vocabulary word is constant. A constant is a term that does not include a variable. It's just a plain old number by itself. It doesn't have a variable. So if you look in this particular expression, you'll see 1, 2, 3, 4 terms. We're looking for a term that does not include a variable. This term has a variable, so it's not a constant. This term does not have a variable. This is a constant. It's a plain old number by itself. This term has a variable of y, so it is not a constant. This term is a plain old negative 8 by itself. So the two constants in this expression are 13 and negative 8. Let's talk about like terms. Okay, like terms are terms that have the same variable part, or we call it the last name, but differ only in their numerical coefficients. So for instance, if I have 2x and 5x, okay, we're going to call the number the first name and the letter or the variable the last name. So when I'm looking for like terms, I'm looking at the last name or the variable part. So since this term has a last name of x or a variable of x, and so does this term here, then these are called like terms. And this is going to be important to know when we get into simplifying expressions down below. So the next example says circle the pairs that represent like terms. We've got 9x and negative 5x. Again, look at the variable part for the last name. The last name of this term is x, and the last name of this term is x. So I've circled this. These are like terms. If you look at the next example, the 7 has a last name of xy, and the 8 has a last name of x. They are not the same last name or do not have the same variable part. Therefore, these two are not like terms. In the next example, these two terms have the same coefficient of 8. Remember, the coefficient is the number in front of the variable. But they do. All right. To simplify an expression, let's talk about what simplify means when we're simplifying expressions. That basically means that when I have variables in an expression, I am not solving for the variable. Remember, to solve, you have to have an equation. These are expressions. They do not have equal sign. So I'm not trying to find out what the variable is. Basically, what I'm trying to do is to just get that expression in its simplest form by combining like terms. And combining like terms means I have to find the terms that are like, which we just talked about, and then add or subtract them together. Your answer will not necessarily look like one number. So let's see what I'm talking about here. When I simplify an expression, I'm going to include the operation in front of each term, and I talked about that a little bit above. Then I'm going to combine like terms by adding or subtracting the coefficients. If there is no sign in front of the coefficient, it is positive, which means plus. So let's take a look at the first one. To simplify this one, I'm going to find like terms. So I'm going to start with the first term. I'm going to put a box around it. That means I'm looking for other terms with the same last name of x here. I go to the next term. It does have the same last name as the first term, so I'm going to put a box around it as well to indicate that these two are like terms. Now, what I do in order to combine is I look at their coefficients, 5 and a positive 3 or plus 3. In this case, I'm adding those together, 5 plus 3, and I get 8. And I have to keep the variable with it, so I have 8 x's. It's the same as if I said, okay, I have 5 x's over here, right here, 1, 2, 3, 4, 5, and then I'm going to add 3 x's to that, 1, 2, 3. When I add them all up, I have 8 x's. But instead of drawing all these x's out, there's a way that I can combine like terms here, 5 plus 3, by adding the coefficients. All right, let's take a look at the next one. The first term has a last name or a variable of y. So I'm going to go down my expression and check each term for a matching last name or variable. This next term is a positive 9. It does not have the last name of y, so I'm not going to put a box around it. The next term is a positive 4y. It does have the same last name or variable part, so I'm going to put a box around this one. This tells me that these two are like terms. What that means is that I can add or subtract them together. I cannot add or subtract any terms that don't have the same variable or the same last name. Okay, so this last term that does not have a variable, I'm just going to circle it. It does not have any like terms in this expression. Now I'm ready to combine the terms that are alike or like terms. These two are like, so then I take and either add or subtract the coefficients. In my calculator, I would punch 8 plus 4, and I would get 12 y's. This positive 9 or plus 9 does not have a like term, so I'm just going to bring it down, plus 9. These two are not like terms. They do not have the same last name or variable part, so I cannot add those together. This is as far as I can go. This would be my answer, 12y plus 9. This expression here represents this first expression in its simplest form. Okay, and the next one, I'm going to put a box around the first term. This term is a constant. It does not have a variable part, so I've got to look for other constants or plain old numbers in my expression. This term has an x, so it is not a constant. This term here is a constant, so I'm going to put a box around it to show that it is like terms with this constant here. I don't have any more constants in my expression, so I'm going to go back to the term that I haven't put any shape around. This term has an x, so I'm going to put a different shape around it than I did the constants. Notice how I grab onto the sign or the operator in front of the term. That is going to tell me whether that term is positive or negative and whether I'm adding or subtracting that term. All right, so I'm looking for another term that has the last name of x, or a variable of x. I've got one right here. I'm going to circle it to show that it is like terms with this 2x. Be very careful. You'll notice here when I circled this that I covered up part of this sign or this operator, which is a plus. It's important that you're able to see those so that you know whether you're adding or subtracting these. All right, I'm going to start with this 2x, and the reason being is that usually the constants in an expression go last. You will normally see those constants last when I list it in simplified form. So I'm going to start with my x term. This is a positive, because there's a plus sign here, 2 plus 6. And that's what I would put in my calculator, 2 plus 6, which is 8x. Don't forget the variable, because we're talking about how many x's we have here. I've taken care of these two, and if it makes it a little easier, you can cross those two out so that you can see which terms you haven't combined yet. I've got a 2 and a 7 that are like terms, so I'm going to punch in my calculator 2 plus 7, which is a positive 9. Since I get a positive 9, that positive tells me I'm going to put plus 9 here. And this is my answer because 8x and the constant of 9 are not like terms, so I cannot add those together. All right, let's look at our other examples here. In this next example, it's very similar to the ones above, except for we have a minus sign here. So again, we're going to identify like terms. This term has the last name of m, or a variable of m, and this term has a last name of m, or a variable of m. So they are like terms. Notice how I grab this minus sign in front of the 5. This is going to tell me whether I'm adding or subtracting this 5. In my calculator, I press 8 minus 5 to tell me how many m's I have. 8 minus 5 is 3, so I have 3 m's. The next example, again, I'm going to identify like terms. I have 10 x's here. I'm looking for other terms with x's. I have a negative x here. Be sure to identify any variables by themselves. These two are like terms because they have the same last name or the same variable part. Now, the last term is a constant, plain old number. So I'm going to put a circle around it, indicating that it is not like terms with these two. My variable comes first, so I'm going to combine them, these two terms. 10 minus, remember we said there is a 1 in front of any variable by itself. So in my calculator I would punch 10 minus 1 and I would get 9 x's. Since the constant of 4 does not have a like term, I'm just going to bring it right down along with the plus sign in front of it. So this expression simplified becomes 9x plus 4. In the next example, I'm going to put a box around the first term. It has an m variable, and there's another term here with an m. There's a plus sign in front of it, so I grab onto it. There are no more terms with m, so now I'm going to go back and I put a circle around this term with a variable of r, and a circle around this term with a variable of r to indicate that these two are like terms. When we write out expressions, we write the variables in alphabetical order. since M comes before R in the alphabet, I'm going to start with my M term first. So in my calculator, I would press 6 plus 3, and I would get 9. So I have 9 M's. I'm going to cross these two out so that I don't get confused when I'm combining the other two terms. Oops. This is 5 plus 10, and I get a positive 15. Since my answer is a positive 15, that positive is going to tell me that I put a plus sign between these two terms, and that's 15R. So my answer is 9M plus 15R. And remember that these two terms cannot be added or subtracted together because they are not like terms. All right, in this next example, these terms are almost exactly like the terms in the previous example, except for there are minus signs here. So I'm going to go ahead and identify the like terms. The M terms are alike, and then the R terms are alike. Notice again, I am including the operator, or also called the sign, in front of the term. So this first term, I'm going to add the two M terms together, 6 plus 3, I get 9 M's. I'm going to cross those two out. Now, when we look at combining the two R terms, we have to be really careful. This minus sign in front of this 5 says that it is negative, and you're going to punch that in your calculator as a negative 5. Subtracting 5 is the same as saying I have negative 5. So in your calculator, you're going to press negative 5 minus 10, and you should get negative 15. That negative in front of the 15 tells you that you need to put a minus sign here. So that's minus 15 R's. Let me repeat that one more time. When you see a minus sign in front of a variable, you need to make sure that you account for it. So in your calculator, you would put negative 5 minus 10, and you would get negative 15. The negative 15 tells you that there needs to be a minus sign between these two terms. This is like saying that this term here is a negative 15R, which is the same as minus 15R. And again, those two terms cannot be combined because they're not like terms. Okay, let's take a look at the rest of our examples. This next example, I'm going to put a box around this 8. This is a plain old number, so it is called a constant. I don't have any other constants in my expression, so I'm just going to leave that alone, and I'm going to go to the next term. I'm going to put a circle around it. Notice I also included the minus sign here. The coefficient on this term is the negative 2. It would be a negative 2 or minus 2, which is the same as negative. I'm looking for other terms with y, and there's one right beside it. I'm going to circle the plus sign in front of the 3 and include it. Now I'm ready to simplify this expression. In my calculator, I would press negative 2 plus 3, and I'd get 1, and that's a positive 1, so I put 1y. I don't need to put a plus sign here because this is at the beginning of the expression. If I don't see a sign here, it's always assumed it is positive. I've taken care of these two terms. I've got this 8 left over. I don't see an operator or a sign in front of this 8, but it is assumed that if I don't see one, that it is a positive 8. So I have to put a plus here to indicate that it is a positive 8. And this is this expression simplified. Now, we don't usually include a 1 in front of a variable. We discussed that earlier. So you would never see it written like that on a standardized test. You would see it without the 1, so it would look like this. All right, the next one I'm going to find like terms. Start with the first one. this first term has a last name of A, so I'm going to look for other terms with the last name of A, and I've got one right here. Again, be really careful to include that operator or sign in front of that term. And be careful that your line doesn't cross through it so you think it is a different sign. Alright, I don't have any more A terms, so I'm going to go back and put a circle around this term with the last name of X. And I've got another term with the last name of X. Here is a constant. I'm not going to put a circle or a box around it. I'm going to put a triangle because it is different than the other terms in this expression. Now I'm ready to go ahead and combine like terms. These two are alike. So in my calculator, I would punch 3 minus 2, and I would get 1. So that's 1A. I'm going to cross those out. Here, I would punch in my calculator, since this is the first number I'm punching and it's got a minus sign in front, I would have to punch -6 plus, and again, there's a 1 in front of this X that we don't see. So -6 plus 1 would give me -5x's. We would write that as minus 5x's. That negative that we get tells us that I need to put a minus sign here. I still need to bring down this constant of plus 4 in my expression, since it did not have a like term. Notice that I put the A term first, then the X term, and last the constant. The constant always comes last in an expression, and the variables are written in alphabetical order. A comes before X in the alphabet. And again, we would take off or erase this 1 here, since we don't need a 1 in front of a variable. Okay, let's look at examples 10 through 12. I'm going to place a box around this first one. It has a last name of XY, which is 2 variables together. Looking down my expression, I don't have any other terms with XY for a last name, so it does not have a like term. I'm going to move on to this term with the Y. I have one right next to it that has the same last name, so these two are like terms. And on the very end, I've got a term with just an X. It is not like the other terms in this expression, so I'm going to put a different shape around it. Okay, I'm going to start with my X term here. X comes before Y, so it comes first. I'm going to write it down since I don't have any other terms to combine it with. I'm going to cross it out. Now the next term that should come would be this one here. The term that should come next would be this one here, this negative 3xy. And I would write that in my expression as minus 3xy. Since it has a negative in front, I would put it in my expression here as a minus 3xy. Now I'm ready to combine the y terms. 8 minus 4 gives me positive 4, or plus 4y's. And I'm going to cross out these two. And this is the way this expression should look after being simplified. Notice I have the variable x here, and the term with xy in the middle, and then the term with y on the end. This is written algebraically correct. However, you're not expected to remember this. This would be I wouldn't count it wrong if you put the xy term in a different place, but we just wanted to show you what this should look like. Alright, next I'm going to place a box around the first term. It is x squared. It has a last name of x squared. I'm looking for other terms with x squared, and I have one right here. So I'm going to put a box around it. Remember, the last name of x squared is not the same as the last name of x. You can think of it as like if my last name were, well, my last name is Johnson. So if my last name is Johnson, then it's not the same as someone with the last name Johnson, which would be like the x squared. All right. Now I'm going to put a circle around this term because it is not like the others. And notice that I did exactly what I said not to do, and that is I covered up the operator there, and I believe it's a plus. So in my calculator, I put 7 plus 3, and I get 10x squared, because they are not the same as x. And then this plus 8x would just come right down because I don't have any other terms to combine it with. And this is how this expression would look. And when we have variables that have exponents, we write them in order, in descending order of their exponents. So for instance, this exponent is a 2, and this exponent is a 1. So the 2 comes first, and then the variable with the 2 comes first, and then the variable with the 1. Something else I need to bring up is that this square, this exponent, only belongs to this x here. It does not belong to the 10 at all. We're not squaring that number. It means whatever this exponent is saying that whatever x is, once we figure out what x is, we're going to square it. But we are not solving equations yet, so we're not ready to do any of that. You would just leave that exponent exactly as it is. All right, last one. I'm going to put a box around this term, which has a y squared for a last name. I don't have any other terms with y squared, so I'm going to move on. Circle around this one with a last name of y, no other terms with that last name, and a triangle around this one, since it is a plain old constant, and I don't have any other constants. We don't have any like terms in this expression at all. So there's nothing for us to do in this expression. We cannot combine these terms together. They are not like terms. Okay, I want to go back to number 11 real quick and clarify something. I thought this was a plus sign, but it's not. It was a minus sign, and I couldn't see it because when I identified like terms, I covered it up. Part of it is because this ink is so thick on the laptop. However, I want to give you the correct answer. Notice how I covered this up. This is an example of how important it is that you're able to see those operations when you're combining like terms. So 7 minus 3 would give me 4x squared. And then I bring down the plus 8x because it does not have a like term that I can combine it with. This would be the correct answer to number 11.